Hello! Today's lesson is on 5.1, Triangle Midsegments. The main question for today is to figure out what a midsegment is. Starting right away, the definition of a midsegment is any line segment that connects the midpoints of a triangle. So if these points here are the midpoints, that means they cut each side in half. So those would be the same length. Those would be the same length. And those would be the same length. Any segment that connects those midpoints is called a midsegment. So that's a midsegment, that's another one, and that's another one. So a triangle has a total of 3 midsegments. In today's lesson, we're going to figure out some special properties of those midsegments, and then we'll do the homework. Shouldn't be too bad. All right, normally I have students draw themselves a triangle and kind of come up with their own conjectures. We're going to kind of do that together instead. So I'm going to just draw a triangle. And I'm going to sketch the midsegment. So I'm going to say the midpoint's about there, and you know what? Let's just connect to one midsegment. So that's a single midsegment. So if I look at that, it appears to be parallel to this side. And in fact, they are parallel. So one of the main things about midsegments and triangles is they're going to be parallel. The other thing that's going to be true is if I look at this distance and compare it to that distance, if this one was like 10, that bottom one's going to be 20. So this midsegment is exactly half the length of that longer one. Now there's a lot of ways we can prove that, but for today we're just going to focus on those properties and make sure we understand them and get them down. So 2 main properties of triangle midsegments. Right here. A midsegment is half the length of the far side, and a midsegment is parallel to the far side. You should probably pause this video, write those 2 down. If you have those 2 things true about midsegments, the homework's not going to be a problem. All right, a couple examples. Here's an example. This is clearly a midsegment. I can tell it's a midsegment because those are the same, so that's cut exactly in half. And those are the same, so that's cut exactly in half. So this line connects 2 midpoints. When that happens, there is a special relationship between that length and that length. It's one of these 2 things up here. All right. A midsegment is half the length of the far side. So if this is a midsegment and it's half the length of that far side is going to have to be 24. Exactly twice as big. All right, let's try another one. This time I've got some variables here. Again, it's a midsegment, so this is definitely a midsegment, so it's going to be half the length of this far side. So if I wanted to figure out what x was, I could try guess and test, but a little easier way would just be to write it. I know that x plus 3 should equal half of the 15. All right, so the midsegment is half the far side. If that's true, then x plus 3 is going to equal 7.5 because half of 15 is 7.5. And then to get rid of that plus 3, we subtract 3 from both sides. X is going to be 4.5. That's the length of x. Which means this x plus 3 is 7.5, which should make sense because 7.5 is half of 15. Right? All right, one last type of problem, and then this video is done. Here I've got one last midsegment. This time I got the one that's going sideways. That's all right. It's still a midsegment because it's connecting the midpoints, right? Those are the same. And so that's going to be half the length of this one. But now I'm not being given lengths. I got to find some angles. So I want to find that angle. And I want to find that angle. So I'm going to have to use the other property of midsegments. If you don't remember that, go back in your notes. The 2 properties is a midsegment is half the length of the far side. All right, we've used that one. Here's the one we're going to use this time. A midsegment is parallel to the far side. So if those are midsegments, they are parallel. And if they're parallel, there's a special relationship between angles. You might remember that this angle here that angle there are called corresponding angles, and corresponding angles are always equal. So if I can figure out this one, I can figure out that one. All right, well, these two add up to a line. A line's 180 degrees. This one here is going to be 60 because 60 plus 120 is 180. And if that one's 60, so is x. All right, y might be a little trickier. To find y, I'm going to have to figure out this angle because they're going to be the same, right? But I don't have anything over here to help me out with that. So instead, I'm going to have to look at something different. Anybody see how I can figure out this angle? All right, one way is to look in that triangle there. Triangles should have to add up to 180. Well, if I take 60 plus 25, that's 85. To figure out how much is left to get to 180, we can subtract 180 minus 85. That's 95. There's got to be 95 degrees left so that all three of these add up to 180. And if that one's 95, so is y. That's it. Those are the two main things we need to work on today. In our class, we're going to do a few more examples like that, and then we'll probably do the homework together. Shouldn't be too bad. Today's assignment looks like a lot of problems, but it's really not bad because a lot of them are problems like this. Like if this was 18, how long is that side? I'm like, well, it's going to be twice as long. It's going to be 36. Really, really fast. Or it might be one like this. If that's 22 degrees, how long is this angle? Or how big is that angle? Well, that angle would be 22 degrees because the lines are parallel. So even though they look like a lot of problems, it's really going to be pretty fast because they're pretty short problems. All right, I'll see you in a bit.